When we talk about a molecule, we're still talking about atoms. Only this time we're not looking at individual atoms and their structure, we're looking at how atoms interact together. Because a molecule is when there is a stable grouping of two or more atoms that are actually chemically bound together. And we're going to look at the two different ways that molecules go about bonding together, and those are ionic bonds and covalent bonds. These two types of bonding occur with different groupings of elements, as we'll see. So ionic bonds happen specifically between metals and nonmetals. And ionic bonds are quite different from covalent bonds because of the way that these actual atoms pair up together and what ends up happening once they pair up. So ionic bonds always happen between metals and nonmetals. And we're going to go over two examples of ionic bonds. We're going to start with a pretty simple 1-to-1 ratio molecule, and we're going to start off with sodium chloride or table salt. So we're going to draw the actual individual atoms, and shockingly enough, valence electrons play a part in the formation of ionic bonds. So here we have two atoms. One atom of sodium, that's atomic number 11, and one atom of chlorine with atomic number 17. So I haven't placed their electrons yet, and I'm going to do so in different colors just because I want to illustrate what actually happens. So we'll look at sodium in blue, and in the first orbit we've got our 2 electrons. Our second orbit we've got 8. Here we go. And our last orbit we have 1 valence electron. That's what makes sodium belong to the alkali metals, is that it is in group 1 and it's got 1 valence electron. Now we're going to look at chlorine, which is a halogen, which means that it has 17 valence electrons. So we will fill this out. Here we go. Now, in its outermost shell, it has 17. So what ends up happening here in an ionic bond? We have metals, which generally are electron givers because they've got too few valence electrons in their outermost shell. So they tend to give electrons to nonmetals, which are electron takers, meaning they've got a lot of electrons in their outermost shell, and it's easier for them to take a few more than to give up all of the ones they have. So what ends up happening here is that valence electron from the sodium right here ends up being transferred over to the valence shell of the chlorine, and in so doing it removes that outermost shell of sodium. Okay, meaning that sodium loses its third orbit and it goes back down to having 2 orbits, and its last one is completely full. It's happy. At the same time, chlorine, which has 7 valence electrons, takes that 1 valence electron from sodium and it causes it to be full in its valence shell. So that means that sodium ends up moving over, okay, and bonding to the actual chlorine. And this is what gives us that sodium chloride molecule. Okay, these two together have 28 protons and they have 28 electrons, making them neutral and stable. Now, what ends up happening here in an ionic bond is when these two, when this atom, or sorry, when this molecule breaks up, when it splits apart, in ionic bonding, when you break up, you don't take your electrons with you. Sodium gave its electron to chlorine, so when they go their separate ways, sodium will no longer be stable, in the sense that it'll have one more proton than it will electrons. Okay? So that means we end up having 11 protons and we end up having 10 electrons. So our overall charge for this atom ends up being a positive 1. Because we know that protons don't ever leave the atom. They're stuck there. They're too big to move. Same thing happens over here for chlorine. Chlorine has 17 protons. It now has 18 electrons, giving it an overall charge of -1. So when these two break up, they no longer have the same number of protons and electrons. But while they are together, they're very, very stable. So ionic bonding is always going to happen with a metal bonding to a non-metal. Now, this giving and taking of electrons is not exactly what happens when we have covalent bonding. Before we get to covalent bonding, I want to show you an example of an ionic bond between two atoms, but it's not a 1-to-1 ratio. So in this case, we're actually going to look at the relationship between magnesium and fluorine. And when these two actually bond, we end up with something along the lines of MgF2, meaning that we're going to have a total of 3 atoms. We're going to have 1 magnesium atom and 2 fluorine atoms. And we're going to talk about why that is. So in this case, when we have a fluorine, that is going to actually give its valence electron to, when we have magnesium and fluorine together, what ends up happening here is magnesium has 2 valence electrons and fluorine has 7. So obviously fluorine is going to do the taking, it's the nonmetal. Now, is this a stable setup? No, it isn't. And it isn't because of this lone electron over here. You cannot make a molecule that has individual electrons floating around when you're bonding ionically. Okay? When you're doing a giving and taking of a metal and a nonmetal, all electrons in this setup have to be bonded to something else. They have to be being used. So how do we actually use up magnesium's second electron? Well, we make another fluorine atom bond to this setup. So what ends up happening here is this fluorine is going to come in here and it's going to bond to the other side of our magnesium, and it's going to take up both of magnesium's electrons. So in this case, in this molecule, we have our 1 magnesium and we've got one of our fluorines bound and the other fluorine. Now, when these break up, we know that this fluorine is going to take one of magnesium's electrons and the other fluorine on the right side is going to take the other. So when they do break up, okay, we are going to have the formation of ions. In this case, though, we're going to have 12 protons and we're only going to have 10 electrons because both of those outer shell electrons are going to be taken. This electron here and this one here are going to go in opposite directions. And that gives us an overall charge of 2+ instead of the 1 plus that we saw on the other side. In this segment, we're going to talk about covalent bonding. Now, covalent bonding, unlike ionic bonding, only happens between nonmetals. Okay, you'll never see a metal in a covalent bond. And as such, in covalent bonds, when nonmetals bond together, they end up actually sharing electrons as opposed to giving and taking. So that when they break up, each individual atom is going to go away with all of its electrons. So we're going to use the example of water, okay? H2O. So when we look at H2O, we know that we have 2 hydrogens bound to 1 oxygen. And in this case, I've drawn the atom of oxygen here. And oxygen has 6 valence electrons, which means it's missing 2 in its outermost shell. So in order for water to actually bond here, we end up having this 1 hydrogen come over on this side, and this ends up working for both atoms. Because if we look at hydrogen, we know that hydrogen is only in the first period, which means the maximum amount of valence electrons it can have is 2. So by bonding with oxygen here, the hydrogen is now going to have that extra electron in its outermost shell, making it stable. The oxygen's not quite there yet, so we're going to add another hydrogen, kind of like we did with our magnesium fluoride here. We're going to add another hydrogen to make this nice and stable. Now, just like before, this hydrogen's going to come in, and what ends up happening here is all 3 of these electrons at this given time, as they are all bound together, are stable. Okay, so this hydrogen has its 2 valence electrons. Its outermost shell is full. This hydrogen is the same thing. Now, if we look at the overall oxygen here, we see that oxygen 2 has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 valence electrons, making it stable. When this molecule breaks up, hydrogen will leave with its 1 electron, the other hydrogen will leave with its other electron, and oxygen will walk away with 6 electrons. So in this case, nobody gains or loses and no ions are formed. So this is the difference between ionic and covalent bonding. Now, ionic bonding is going to become very important later on when we start talking about acid-base neutralization. So that'll be in a later chapter. But in order for us to understand how molecules behave, we need to understand how they're formed. And these are 2 ways that atoms are actually formed, or molecules are formed, I should say. We have this giving and taking in ionic bonding, and we have this sharing in covalent bonding.